Okay, let's continue our video with this number 6. So I'm going to go ahead and go to back to the box method on this one here. This one, I know that this box is going to be a little bigger. So draw a box a little bigger. I know that I can just see because it's a larger polynomial. And then go ahead and write your numbers out to the side. 3x minus 1. Write the numbers across the top. Remember, when we're multiplying, we put our polynomials on the outside. At least that's what we practiced in class. Just like our multiplication chart. The values were on the outside and their product was on the inside. So product means multiply. 3x squared, or 3x to the first times x squared. Multiply the coefficients. 3 times 1 is 3. X to the first, x squared. Add the exponents. That's x to the third. 3x times 2x. They're both positive. That is 6x squared. 3x times negative 5 is negative 15. And there is single variable x. Now we're going to look at negative 1 times 1x squared. That gives me negative x squared. Negative 1 times 2x is negative 2x, and negative 1 times negative 5 is positive 5. That one has no values of x. First term, 3x cubed. That's called a cubic term, C-U-B-I-C. Then we have our quadratic term, negative x squared plus 6x squared, so 6 minus 1 gives me positive 5x squared. Linear term, negative 2x minus 15 is negative 17x. And then our constant term, positive 5. All right. If you're comfortable with distribution, you can definitely do distribution, but you're going to have 6 values that are listed out, right? You should find all these same 6 values, and then you would go through and combine like terms, so you would end up with 4 terms in your polynomial. All right, let's go to number 7. Now, on number 7, they're asking me to factor out the GCF. So factoring means we're doing the opposite of multiplying. We are looking for the greatest common factor, which means that's similar to dividing. So I'm going to go ahead and start with the 3 terms that we have. I'm going to make our area model. This time we have the solution. We don't know what they were multiplying. So this time it goes in the box. We have to find what they were multiplying by. Now on this one, I actually don't need to find both polynomials. They only asked me to find the GCF. So what is it that they were dividing by? When you're trying to find the greatest value, or the GCF, I would always start with the smallest number of the 3. Can they all be divided by that number? So 6 can obviously be divided by 6. 18 can also be divided by 6, so that means negative 18 can be divided by 6. And 12 can be divided by 6. So their GCF has 6 as part of it. That's the value. Okay? The smallest one has a single x. Second one has x squared, and this largest one has x to the third. So they all have x in common. So their GCF for this one is 6x. Okay? They did not ask me to find both pieces. They only asked me to find the GCF. So that's what I'm looking for. All right, let's go on to number 8. Now, number 8 says, what is the quotient of the given expression? Quotient is another one of those words that asks us to divide. Right? So I'm going to use the area model, and then I'm going to show you a second method as well. If I'm using the area model, this is the answer. So that's what's going to go inside of the box. So there's 3 terms. It's a trinomial. So let's go ahead and put those 3 inside our box here, 6x to the third plus 9x squared minus 3x divided by 3x. This is our GCF. If they tell us they're dividing by that, that is the GCF. They're asking us on this one to find what's the other part they were multiplying by. So we're going to take the value on the inside divided by the GCF. So 6 divided by 3 is 2. X to the third divided by x, this is when we subtract. 3 minus 1 is 2. 9 divided by 3 is positive 3. X squared divided by x leaves me with x. Negative 3 divided by 3 is negative 1. X to the first divided by x to the first is no x's left. So this here would be my other polynomial that we are multiplying by. Okay? That's the other factor. All right, so let me show you a different way for dividing if the box confuses you with dividing. I had some students say, can I just use the box for multiplying and not use it for dividing? Yes, you can. So let's go ahead and look at this other method. If I take the first polynomial, that will be my numerator. The second polynomial will be my GCF, which goes in the denominator. So if I have 6x cubed plus 9x squared minus 3x, they're all being divided by 3x. Well, that 3x is a common denominator. So if it's a common denominator, that means each term is going to have its own denominator of 3x. Now when we divide, we're dividing each numerator by that denominator. So 6 divided by 3 gives me 2. X to the third divided by x to the first, 3 minus 1 is x squared. Then I look at the next one. 9 divided by 3 is positive 3. X squared divided by x to the first, 2 minus 1 is x to the first. Then the last one, I've got negative 3 divided by 3 is negative 1. X to the first divided by x to the first, 1 minus 1 is 0, so that one has no x's. Okay? So either way, those answers, okay, that does not want to circle. Those answers will come out identical, right? So 2 methods in which you can find the quotient. All right, so this next one, what is the quotient of the given expression? Well, this is a great example to see that the numerator is placed on top and 5x is the denominator. Now remember, 5x is the GCF. So if I wanted to rewrite this, I could rewrite it as 10x third divided by 5x minus 25x squared divided by 5x. 10 divided by 5 and negative 25 divided by 5. 10 divided by 5 is going to be 2. 3 minus 1 is x squared. Negative 25 divided by 5 gives me negative 5. 2 minus 1 gives me x. Also saying that you could do this one with the box method is absolutely true. You can do it with the area model with the box method. Don't know what all that's about. All right. All right, last one, rewriting it in standard form. So writing something in standard form is just putting it in order from the largest exponent to the smallest exponent. So which one has the largest exponent? X third, but keep in mind that this is a negative x third. Okay? So negative x third. Now which one has the next highest exponent? Well, that would be negative 2x squared. Always looking at the exponent when we're writing in standard form. So then that next one would be positive 6x. And the last term is going to be our constant term. It is a positive 4. All right, that is it. Again, version B is here if you want to practice it, and the answers are on that last page of the document.